Good evening. My name is Lim Yao Shun from USM Material Engineering. This subject is EBB308 Material Selection and Design Analysis. In this assignment, we are going to run a Solidwork simulation on the heatsink. So, this one is the isometric view of the heatsink. There will be a front view, side view, and a top view. So from these three directions, we are going to apply force. The force will be different from 1 Newton, 5 Newton, and 10 Newton. And from this, we are going to compare the stress, strain, and displacement. Before I continue to my slide, I will going to simulate the SolidWorks. So this one is the heatsink isometric view. So now we are going to create a center point. So I will take an example of this front view. First, we are going to sketch. So let's sketch a corner rectangle. Selecting the whole area. Next, we are going to draw a center line. Alright, so after the center line is done, we select OK. Okay, now from this feature, we can select this reference geometry, select point. So from this cross, we can generate the center point at here. Now we can run the mm, okay, now we will need to run the simulation. So we can add a simulation here. We are going to select a new study here. Since it is the front view, so I will going to name my study front view. So that later if I do the side view and top view, I can uh, differentiate them. Now we are going to first apply a material, which is aluminum. Let me check. So I have already selected this aluminum alloy. So apply. Next is to add a fixture. So the fixture is added below here at the bottom. Now apply force on the point. We select this point and then select direction. And we are going to select a direction that is parallel to the direction that we want. So that like this one, yeah. So now the direction is pointed outward. We are going to change the direction. Select this reverse direction so that the force is acting towards our heatsink. So if we choose this direction, this one is a parallel to the force that we want. Let's say we are choosing a direction on the top view. So we are going to select this line so that our force will act it downward. And again, if you are doing on the side view, at the side is direction from the side. So we are going to select this line so that the force is parallel and acting on our heatsink. So going back to our front view, we are going to choose the force can be 1, 5, and 10 Newton. So I will do the 1 Newton first. Okay, after this, we are going to run this study. First, create the mesh. And then run this study. Alright, so this one is the one that deformed already. So from here, we can see that this one is the maximum, which is 5.164 to the power of 5 Pascal. And the minimum stress will be 1.674 to the power of negative 3 Pascal. So we can also compare the displacement and also the strain. So for displacement, we can see that the maximum displacement will be 3.464 to the power of negative 5 mm, and the minimum one is 1 to the power of negative 30 mm. Let us see the strain. Yeah, so the strain will be the maximum at the 7.084 to the power of negative 6, and minimum is 3.451 power negative 14. We can also compare results so that you can see all of the results clearly together. So from here, this one is the mm, from here we can see that this one is a stress, this one is a strain, this one is a displacement, and this one is the original one that our mesh. Okay, so if we are going to change another direction, the method will be the same. So my explanation on the simulation will stop until here, and let us continue to our slide to compare all of the results that I gained. So we are going to compare on the first direction, which is the front view. This is the one that I simulate on the Solidwork just now. And in this slide, we are going to compare on the stress. We have applied the load of 1 Newton, 5 Newton, and 10 Newton. And we can realize that each of the load given, we can actually get the result of the maximum and minimum value that is recorded at Pascal. So from 1 Newton to 10 Newton, when the load is increasing, the maximum value of stress is increasing and the minimum value of the stress is increasing as well. And we can realize that at the smallest load at 1 Newton, the maximum and minimum value is the smallest. The difference is the smallest, while the load of 10 Newton, the difference between the maximum and minimum value is largest. And then we are going to compare on the same direction, which is the front view, but now we are going to compare on the strain. So for the strain, it's still the same. We have three loads, which is the 1 Newton, 5 Newton, and 10 Newton. We can realize that when the loads increase to 10 Newton, the maximum value of the strain is actually decreasing. Means that the magnitude of the value is becomes smaller. It's only recorded at 7.084 times 10 to the power of negative 5, while the minimum value is recorded at 3.451 times 10 to the power of negative 13. This might be weird, but it can be explained that strain is often a dimensionless quantity, meaning it is a ratio of change in length to the original length. And SolidWorks might be normalizing the strain value based on the original undeformed geometry. In this case, a smaller force of the 1 Newton would cause a smaller absolute change in length, resulting in a larger strain value. So you can see that the strain value here is quite large comparing to this one. So this one is 108 and 16,000 something the value, and for 10 Newton the value is actually only 11,000. So just like I said just now, because of the smaller force, 1 Newton would cause a small acceleration in length, resulting in a large strain value compared to the larger force, 10 Newton, will cause a bigger absolute change in length. And now we are going to compare on the same direction, front view, and we are going to compare on the displacement. So we can realize that the maximum value is decreasing. It's decreasing from 1 Newton to 10 Newton. And the minimum value is remaining the same of 1 times 10 to the power of negative 30 mm. So we can realize that when the load is increasing, the difference between the maximum and minimum displacement will be increasing as well. Now we are comparing on the side view. This is the stress, and the result is quite the same like the front view. As the load is increasing from 1 Newton to 10 Newton, the maximum and minimum value is increasing as well. And the difference between the maximum and minimum value is smallest at 1 Newton and the largest at 10 Newton. This one is the strain. You can realize that the maximum and minimum value has a larger magnitude at the 1 Newton load and a smaller magnitude at 10 Newton load. So the maximum of 10 Newton load is 5.057 times 10 to the power of negative 5, while the minimum value is 4.153 times 10 to the power of negative 13. And this one is a displacement, and the minimum is still the same, which is the 1 times 10 to the power of negative 30 mm. And when the load is increasing, the difference between the maximum and minimum value will be increasing as well. And this one is the top view. We are comparing the stress. So the maximum value and minimum value can be seen at here. So for the maximum load, the maximum value of the stress will be 3.463 times 10 to the power of 6, while the minimum value will be 1.368 times 10 to the power of negative 2 Pascal. And this one is a strain. The explanation is the same as well. But we can see at a 10 Newton load, the minimum and maximum value have a smaller magnitude, which recorded the maximum at 4.608 times 10 to the power of negative 5, while the minimum is the 1.494 times 10 to the power of negative 13. Lastly, is a displacement. It's quite the same, while at the maximum load of 10 Newton, you can see that the maximum value is at 2.614 times 10 to the power of negative 4, while minimum value is same as the other load, which is 1 times 10 to the power of negative 30 mm. This is the conclusion that I made after the SolidWorks simulation. I have realized that the difference of maximum and minimum stress, strain, and displacement varies when different amount of force, which is the 1 Newton, 5 Newton, and 10 Newton is applied. The largest strain difference is when the force applied from the front, and the largest stress difference and the largest displacement difference is when the force applied from the side. This is because of the large surface area of the side of the heatsink. That's all from my work. Thank you very much.